everyone. In this video, we are going to run through some examples, applying the knowledge we just learned in our first video, explaining the definitions of what's going on here. So in this picture, I want to first determine whether I'm working with a central or inscribed angle. And I see that the angle is starting right in the center. So remember, center, central. So in this box, I'm writing central, and this is going to be very helpful for you in your task. Central, right? And I remember from a few slides back that when I'm dealing with a central angle, the arc is equal to it. So the measure of arc AC is equal to my central angle. Now, is this a minor or major arc? So we look at how big arc AC is. Now, it's not very big. It's definitely less than 180 degrees. And remember, 180 degrees is half of a circle. So because it's less than half of a circle, we call this a minor arc. So I'm going to write minor. Now, your last question will be to find the arc measure. And because my angle, the measure of angle AOC, is 32 degrees, the measure of the arc AC is going to also be equal to 32 degrees. So they're the same because they are central angles. So right here, I'm going to write the measure of arc AC. Remember, this is the symbol for arc, equals 32 degrees. Okay, so central angles should be fairly simple and straightforward to see. Let's do another example. So here in example 2, I am given that the measure of angle AOC is 32 degrees. I already know what it is, which means that this arc, the measure of arc AC, is also 32 degrees. So this problem is not asking me what the measure of arc AC is. I already know what it is. I need to solve for x. So first, let's fill out this box. Now, are we dealing with an inscribed or central angle? This angle starts at O, right? So it is a central angle, starts at the center. Just like before, it's a minor arc because it is only from here to here. This is definitely less than 180 degrees, right? It's pretty small, so we call it a minor arc. And our arc measure, we already know that a central angle is the same as its arc measure. Its intercepted arc is the same exact measure. So I'm going to write the measure angle arc AC equals 32 degrees. Now, I need to solve for x. And if I know that arc AC is 32, I can put that in and solve for x. So instead of writing, well, I'll write it first. I'll set up my equation. So arc AC equals 5x plus 2, and I need to solve for x. Now, luckily, I do know what the measure of arc AC is, and that measure is 32 degrees. So rather than writing arc AC, you're going to write 32 degrees equals 5x plus 2. And now you would just solve for x using a normal solving for x equation. So it's just one unknown, so I'm going to subtract 2 from both sides, right? I want to isolate x. I want x to be alone. I cancel off this 2. 32 minus 2 is just 30. Right here I have 5x. What I'm going to do to the 5 is divide it off to both sides so that I can cancel it and isolate x alone. And I'm left with x equals 6. That's my answer. So I solved for x. Okay? Now, this is example 3. So here, this angle looks much, much different, right? It's not starting in the center of the circle. It is starting, it is inscribed, it's starting on the edge, so it's definitely not central. It doesn't start in the center of the circle. So this is a inscribed angle, so I'm gonna write inscribed here. And I look at arc AC, so I'm gonna go ahead and highlight it. And this intercepted arc, right? A and C intercept the circle to create arc AC. It's definitely smaller than 180 degrees, right? 180 degrees would be half of the circle. This is only a little piece of it. So this is a minor arc. Okay. And now I need to find the arc measure. So I know this angle is 32 degrees, but what do I know about inscribed angles? The arc created by an inscribed angle is double the angle itself. So that's going to be, so the measure of arc AC equals 2 times 32 degrees. So that means that the measure of arc AC is going to be 64 degrees. That is my answer. So since this is 32, it doubles to grow. So 64 degrees is my answer. That is how you do example 3. And then we're going to do one more example where we are given the arc and we need to go backwards. So looking at this example, I can tell very easily that this is not a central angle, right? It's not starting at the center, so I can cross that off as an option. This is an inscribed angle. And again, it is a minor arc because the intercepted arc is small. I already know what it is. It's 80 degrees, smaller than 180. So this is a minor arc. And now I need to find the angle measure. So I don't know the angle on this picture. This is angle A, B, C. I do know that the arc is 80. Now when I know the arc and I need to go back to find the angle, I have to actually divide by 2. So when I'm growing, I multiply by 2. But if I already have the arc, I need to divide by 2 to get back to where I need to be. So I'm going to write the measure of angle A, B, C is equal to the measure of arc AC divided by 2, right? So again, a fraction line is just hitting the divided button in your calculator. So the measure of angle A, B, C is 80 degrees divided by 2. So arc AC is 80 degrees, so I plug that in here. I'll highlight that orange. And 80 divided by 2 is 40 degrees. So the measure of angle ABC equals 40 degrees. So that's what I'm going to write right here. So as you can see, if I'm given the arc, so when you're doing your task, when you're given the arc and it's whatever degrees it is, you need to divide by 2 to go backwards, to get back into the angle. Now, if you're given the angle and you want to go out to the arc, you multiply by 2. So depending on what problem you're working on, you can review that example. So example 3 starts at the angle. Example 4 starts at the arc. I hope this video helps. If you have any questions, please email me. I hope you're all doing well, and I will see you in my next video.